Good afternoon, grade 8s. We are doing parallel test 3A this afternoon. This is the follow-up test to class test 3A. So just keep up with all the names. We are just going to look at the answers to the second test. So that's called parallel test 3A. It is a test parallel to the first one, meaning that it looks very similar to the first one, and basically only the numbers and variables have changed. And the idea is for you to, of course, learn from the first test in terms of the mistakes that you made, and then obviously trying to do hopefully much better in the second one. Our first question deals with the laws of exponents, as we can clearly see here, and our instruction is to simplify the following. 1.1.1 then is y to the power 5 multiplied by y multiplied by y to the power 5. Same thing really. I then have a base here of y multiplied by the same base, so we can keep the base, which is y, and then add our exponents. So that would be 1 plus 5, and our answer is then y to the power of 6. 1.1.2, x to the power 18 divided by x to the power 9. If you recall back to our previous discussion in worksheet or class test 3A rather, we noted that it is always better to write a division sum. So in other words, here where you have a division symbol, it is preferable that we write this over as a fraction. So x to the power 18 over x to the power 9. And then if we think about the fact that we have two powers being divided and those two powers have the same base, we then have x to the power 18 divided by x to the power 9. So I can keep my base, which is x, and subtract my exponents, not divide my exponents, subtract my exponents, and that of course with the x to the power 9. A lot of you did this. If I can just use a different color here, a lot of you had, I've got x to the power 18 over x to the power 9, and then you said my answer is x to the power 2. And the reason you wrote x to the power 2 is because you decided to divide 18 by 9. We do not divide the exponents, we subtract the exponents. So that is wrong. 1.1.3, we have b to the power 8, which is a power raised to another power of 5. So this is a power raised to a power. So once again, if you recall back to our laws, when we have a power a to the power m, or if you have the power a to the power m raised to the power n, we can simply multiply the exponents m times n. So applying that rule, I can say this then will be b to the power 8 times 5, which is b to the power 40, just applying the law there. So not b to the power 13, because we are not going to be adding the exponents, we are multiplying the exponents in this case. 1.1.4, we have a fraction here, k to the power 5 raised to the power 6 in the numerator. And then k to the power 3 times k to the power 5 in the denominator. So I will deal with my numerator first. In my numerator, I've got a power raised to a power, so I know I can just keep my base and multiply the exponent. So that's 5 times the 6. And in my denominator, I've got the same base, so I have k to the power 3 times k to the power 5. So I've got the same base, so I can keep my base and add these guys, add my exponents. So that means I can keep my base, k, and say 3 plus 5 now, not 3 times 5. Simplifying, I've got in my numerator k to the power 30 over k to the power 8. And once again, many of you stopped at this point and said, I'm finished now. I'm not finished because I can simplify further. The idea here is to simplify. When we say simplify, we mean simplify as far as possible. So this means I can go one step further and divide. I can divide because my bases are the same, which means I can apply the law that says I keep my base of k and I can subtract the exponents. Okay, that kind of didn't work in sync there, but I will keep the base of k and subtract the exponents. So that looks as follows. I have k, I subtract the exponents, and I end up with k to the power 22.